Hello and welcome back to the lab for my fourth video on my walking robot project. Today I'll be modifying the robot's gait behavior to make it faster, more stable, and more power efficient. The code uses a Bezier curve to define the robot's foot position as a function of time. The math behind this function is somewhat complex, but a helpful graphing website called Desmos makes designing and visualizing Bezier curves very simple. You can play with it by clicking the link in the description below. It runs in a web browser, so you can get started in seconds. What we see here on the right is the robot's baseline gait. I'm going to modify the control points to make the robot pick up its foot more abruptly and lift its leg higher as it takes a step. So I can just move these points around, and now you can see the shape of the curve is changing. And I'm going to go with something more like this. Once you're happy with the overall shape of this curve, you can open up this tab and find the coordinates of each point. Now we're going to copy the values out of this table and put them over here into this function. Alright, now we've finished modifying the code and we're going to save these changes. We'll run those changes and see what happens. Just to see what happens, I'm going to put in this more square-shaped gate. So it looks like the square gate, I can get a little bit more speed out of it. So the brake looks pretty bad. I think I'm going to have to completely replace it. Actually, there's another option to fix this brake. You just use some super glue. So I put super glue on there and I'm using a shrink wrap cast to hold everything in place. Okay, it's been several hours and now I'm going to cut back the heat shrink. Alright, seems like everything's dried up. Okay, it broke again. Well, it turns out it only takes 15 minutes to print this out, so I might as well just make another one. I want to make sure that the robot's getting enough power, so I'm going to start using this ATX power supply. There should be a sticker on the side that tells you how much current and power it can supply at each voltage. These wires are color-coded. The green wire can be shorted to any black wire to turn the power supply on. The red wires carry 5 volts and the yellow wires carry 12 volts. I need a supply of 5 volts for my project, so I'm going to cut some red and black wires and hook them up to this connector. These wires are good for about 10 amps each, so I'll need at least 3 red wires and 3 black wires. I fixed the broken leg and redid the wiring so that most things are off board. Now I have the new power supply set up. There's just one thing missing. I have to steal the shoes off of the dead leg. After dropping the robot off the table, I only had 2 parts break. One tibia and one servo horn, which stripped out. It looks like my robot developed a twitch from the traumatic experience of falling off the table. This is pretty weird. Now the robot's walking on 2 legs. Wow, I can still walk forwards and backwards just fine. Alright, thanks for watching. If you like these videos, make sure to smash that like button and subscribe so you can see my next video, where I'll be showing you how to design your own walking mechanisms, and I'll be checking out a new laser mapping sensor. Thanks and bye.